All right, 11.2 continues looking at quadratic equations. We're talking more about the graphs now. If you remember from 11.1, our standard form is y equals ax squared plus bx plus c. That a actually tells us quite a bit about the equation. If a is positive, our u is going to point up. And if a is negative, the u is going to be flipped and point down. Now that we've paid attention to that, we can look at the absolute value to decide how fat or thin the curve will be. So if a is 1, we have what we call a normal u. It's just the standard width. If a is bigger than 1, then it's going to go up faster. So it's going to be skinnier or more narrow. Narrow. And then if a is less than 1, it's going to be wider, looking more like this. Using that information, if we were comparing these two, the negative tells us it's going down, and the 3 tells us it would be skinny. So let's check it out. If I put f of x here, x squared, and then here I put negative 3x squared, we look at them. The blue is our normal. The red is skinnier and flipped. So we can compare them. Another type of way they change is called a translation or a slide. So you can slide either up or down or left or right. Up or down would be on your y-axis. So if you're adding a number to it, you're going to move it up. And if you're subtracting a number, you're going to move down. So let's see that on the calculator. Blue, we're going to have x squared plus 1. Red was x squared minus 2. And then we'll just do an x squared in the middle to compare. So the blue one has moved up from the black and the red has moved down. Left and right is the same idea. We're just inside the parentheses this time. So we're going to do the opposite. It always ends up being the opposite when you're in the parentheses. So that negative is actually going to move us to the right, and that positive is actually going to move us to the left. So let's see how those look on a graph. Oops, I don't know why I deleted that one. Clear? Clear? All right, so we have x minus 1 squared, and then we have x plus 2 squared, and then for reference, we have x squared. So the blue one has moved right, the red one has moved left. It's the opposite. That's the biggest thing to remember is when you're in the parentheses, you do the opposite of what you'd expect. If we put those 3 pieces together, we have the vertex form of the equation. The same a we had before, but now we have the hk, which is our vertex, put into there. So if you were going to graph these, you can, find the vertex on the graph and then compare it to the original. So the vertex of the original is 0, 0. Our parent function is 0, 0. If I then did x plus 2, or x squared plus 2, x squared plus 2. If I graph that, one way to find the vertex is to do the second trace maximum from, we talked about that in 11.1. We put our arrow somewhere to the left of the min, somewhere to the right of the min, or don't have a max because I chose the wrong thing. We should be doing the minimum on this. So let's try that again. Left of the minimum, right of the minimum. Our min is 0, negative 2. Or 0, positive 2, sorry. Which is 2 above the original. That makes sense. We went up 2. This one we're inside. So we're saying it's moving left 3. So our vertex should be negative 3, 0. Let's check out what happens. Parentheses, x plus 3 squared. Second trace minimum. Somewhere to the left, somewhere to the right, and our minimum is negative 3, 0. If we put those together, the opposite of this is 2. and that's -3. So on the graph, that would be our vertex. Looking at this one, our vertex is going to be the opposite of this, comma 2. So there's our HK. And then this A is 1/2, so that should make it wider. Let's check it out. So we have 1/2 x minus 5 squared plus 2. That is, in fact, wider than the original. All right, so this last one, -5, -3 is our vertex. This is going to make it skinnier or more narrow, and this is going to flip it so that it points down. That's using the rules. Now let's see it on the graph. X plus 5 squared minus 3. So we're skinnier, we're flipped, we're moved left and down. That's how that works. Now the equation, if we look at this one, that models this form, ax minus hk. So if you're given those three values, you can plug it right in. Y equals, a is 2. We do the opposite of h, so I'm going to put x plus 2. Our squared is what makes it quadratic. Add 1 at the end. If you remember how to find the vertex, putting it in vertex form is pretty easy. H is -b over 2a, so it'd be -6 over 2 times 3. 2 times 3 is 6. -6 divided by 6 is -1. So that's our H. K, we plug that in. So 3 times -1 squared plus 6 times -1 plus 1 gives us -2. That's our K. The A is the same A. Now we can plug those in. And that would be the equation. If I graph both of these on the calculator, you're going to see they're the same exact curve. You try putting the three of these in vertex form. Pause the video and then check how you did. All right, opposite of b over 2a gives us 3. Plug 3 in. We get -10. The a is 1, so we plug those in just like this. There we go. You could put the 1 here. That's completely up to you since multiplying by 1 doesn't change anything. All right, -b over 2a gives us -1.5. Plug that in. Don't forget your parentheses if you're typing this right in the calculator. Otherwise, your order of operations will overrule you. So 1.75. A is 1. Opposite of H plus K. All right, last one. Opposite of B over 2A gives us -1. Well, let me switch my colors. If we plug -1 in for X, we get -3. The A is 2, so we need to put that in there. Opposite of H plus K. All right, the last thing we're going to look at with this quadratic is to find the value for the constant A so that R of X equals A times X squared. So it's saying if we put X in, square it, and then multiply it by some number A, we'll get R. That's what this is telling us. We want to find the A. We can pick any point and check it out. So let's pick this point. Instead of R, we're going to write 200. We don't know A, but instead of X, we're going to write 20. Well, 20 squared is 400. And if we divide both sides by 400, we get 1/2 equals A. Now, let's say, I just want to show you, let's say you picked a different one. Let's say you picked this one. We would do 1800 equals A times 60 squared. 60 squared is 3600. Divide both sides by 3600. And we still get 1/2 is A. Then we could use that equation to find anything else. That's 11.2. Let me know if you have any questions.